Welcome to yet another video. This time around, we want to um, do graphical analysis or graphical interpretation of certain concepts. We'll be looking at the range and then the domain of certain functions. Where possible, we'll look at the x and y intercept. So let's kick off with this function x squared plus 4x plus 4. We want to look at how we'll be able to find the domain. Remember, the domain talks about the x values, whereas the range talks about the y values. So let's look at the range of x values which are affected by this kind of function or curve. If you look at it critically, let me try to zoom it down. You realize that this curve will go endlessly from the negative x side to the positive x side. It goes endlessly. Therefore, we can say that the domain is a set of all real numbers. The domain is a set of all real numbers. Now let's look at the range. Remember, I said the range talk about the values of y that are obtained from the function or the curve. So trying to zoom out, let's see. If you observe critically, you realize that the first value of y obtained at this level is 0. Looking at the origin, see at this point there's an intercept with the x-axis. So it implies that we are getting the value of y to be 0 here. So the first value of the range is 0. And when it's 0, where does it go to? It goes up, 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 up until infinity. So the range for this curve should be from 0 to infinity. From 0 to infinity. And this description is perfectly fitted in the analysis of the calculator. Remember, we said the domain talks about the value of x. So the x or the domain of this function or this curve is the value or all real numbers, whereas the range talks about the value of y. And looking at where it starts, y starts from 0 up till infinity, and that's what we have here. Now, when I was trying to explain that of the value of y, I was tracing it to the negative 2 here, which is actually the intercept of 2. Remember, at any intercept, x-intercept y is 0, and then y-intercept x is 0. So let's quickly look at where we have the y-intercept. At y-intercept, we get x to be 0 to other point, y is also 4, and that is indicated as expected, right? Now, since this one is actually a minimum curve, let's take this opportunity to analyze the minimum curve. Now, since the minimum curve, it means that we can get the minimum point, and the minimum point is the lowest point of the curve, right? And the lowest point of the curve give us the point negative 2 and 0, right? So let's quickly go to a different function, this function, which is the root kind of function, and let's see what we can get. Now, so if you look at what we have here, you will realize that talking about the values for the 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 the, the domain, you realize that x starts from a certain value and it goes to a certain unknown end, because pulling it at this end. So the domain should start from negative 4 up to infinity. The domain should start from negative 4 up to infinity. Whereas looking at it critically, the range of this curve, actually from negative 4 we are getting 0 here, and it cuts across going down. At this point we don't know where it ends. It's an infinite curve. We actually don't know where it ends. So the um, range should be from 0 to infinity. Let's see what the curve is actually being talked about here. Now, so um, like we said, this calculator give a precise interpretation of what I was trying to say, where we say that the domain is from negative 4 upwards to positive infinity. He has tried to make it greater than negative 4, and we equally said the range should start from 0 up to infinity, like we said. Now, in this case where we have negative 4, we are told that negative 4 at this point is the y-intercept, sorry, the x-intercept, because at that point y is 0, and this point, which is 2, is the y-intercept. Good. And notice that this is the barest or the lowest point of the curve becomes the minimum or the minimum point of the curve, right? So let's quickly go to this other curve. Now this curve, actually looking at it critically, you realize that um, it has some form of discontinuity, which means it's not a continuous curve. Now, to deal with this curve, or for this function to be valid, we need to ensure that the x value is not equal to 0, or else it will be undefined. Sake of this, you realize that in analyzing it, you have x not to be equal to 0 for the domain. On the other hand, the range should be the set of all real numbers. Notice that the curve gets as close as possible to the individual axes as x and y, but doesn't touch it. In view of that, there is no defined minimum or maximum point, right? So quickly, let's go to that of the sine or the trig curve that we have here. Now the sine curve, let's try to zoom it out to get the precise definitions of what we want to identify. Now you realize that the range, the 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 the, the domain actually is it moves from certain values of x going up, going up, going up, and we don't know where it even starts from. So it means that the domain should be the set of all real numbers, right? A set of all real numbers. But then the range, looking at how far it goes and come, looking at, let's look at how you see that if you compare the lowest point of the curve has y to be negative 1, and the highest point of the curve has y to be positive 1. That implies that the range should be the set which is negative 1 to 1 inclusive, right? Now the intercept has certain points where you see where talking about angles, so they are being spoken about in radians actually, right? In radians. Okay, so let's quickly go to the cos curve. So the cos curve also gives us a certain picture similar to that of the sine curve, where we can talk about the range being a set of all real numbers, the domain being a set of all real numbers, and then the range being from negative 1 to 1, as in the case of the sine, whereas the intercept, it does the x-intercept given its radians because of the angular character of the curve, whereas the y-intercept at the point where the x is equal to 0 is at 1. Let me quickly go back to the sine curve and let's talk about the y and then x intercept. Now look at the x-intercept is in the form of an angle, but in the case where we have the y-intercept, x is actually equal to 0. So let's see. So at the y-intercept which is equal to 0, so this is a point where x is equal to 0 in the curve. I believe that you have been blessed by this video. Thank you so much for watching.